to is given something, we're going to throw it onto a coordinate plane, and then we're going to talk about how we can use geometry to prove or to solve for something. So these are your general strategies that you're going to be using if you're asked to do like a max or a min problem. These are in the textbook too. So general strategies for solving max-min problems. Give you a second to get yourself organized. All right, so our first thing that we always want to do, which is helpful for me because I am a very visual person, I'm a visual learner, is to create or draw a diagram. So create that diagram and then label the vertices of your geometric figure within that diagram. And sometimes you're going to have to be strategic with the way that you want to label those vertices, because they might just not be as nice as 2, 3. We might have to use generalized variables to represent our ordered pairs. Okay, so make our diagram, label vertices of our geometric figure. Number 2, we're going to determine an equation for the quantity to be maximized or minimized. So come up with our equation, which means we're probably going to have to do some type of composition of a function to put something in terms of just a variable. All right? Remember way back when we were doing like area and plugging in things for area to get it in all terms of X, or I think there was something with profits and costs and revenues and all that good stuff. Okay, so we're going to create an equation for our quantity to be maximized or minimized. Number 3, we're going to use the information in the problem to express the equation in terms of one variable. So there's your composition. So we're going to try to create an equation that just has one variable in it. And then we're going to analyze the equation to determine a max or min value. So thinking back to section 2.5 when we were talking about quadratics, if I know that my quadratic is concave down, is my leading coefficient positive or negative? Negative, right? Which means I'm going to have a max or a minimum. If I'm concave down, I'm going to have a max, right? If I'm concave up, I know that my leading coefficient, my A, is positive. And if I'm concave up, then I know I'm going to have a minimum, right? That's stuff that we know already. So if I can get some type of parabolic quadratic equation, then I know I can find a max or a min. All righty. Okay, so our first example, we have a second parabolic slide is to be built with a rectangular storage shed under one arch of the slide. So we have a parabolic looking slide, so our parabola. Underneath that slide is going to be a rectangular shaped shed. They're giving us the equation of the parabola is y equals 20 minus 0.32 x squared. I don't know why that s is in there. Let's get that out of there. Using two-dimensional model of the curve and the storage shed, determine the, that's probably supposed to be using A. Using A, two-dimensional, not S. Using a two-dimensional model of the curve and the storage shed, determine the maximum perimeter in feet of the front side of the shed. Okay, so what do we have happening here? We got an equation. That's quadratic, that's good. Is that equation concave up or concave down? Concave down, which is good because I need to have a maximum perimeter of the front side of this shed. Okay, so let's see what this looks like. Let's make a diagram. I'm going to do my diagram up here. So I'm going to create a coordinate plane. I'm only really interested in quadrant 1 and quadrant 2. So here's my coordinate plane. I'm going to put a parabola that's symmetric over the y-axis. That's concave down. So there's the slide. It says we have a rectangular storage shed underneath that. So there's my rectangular storage shed underneath the parabola. Okay, so I know that the equation of this parabola is y equals 20 minus 0.32, I'm running out of space. Y equals 20 minus 0.32 x squared. I want to find the maximum perimeter of the front side of this shed. So now what we're going to do is we're going to label the vertices of my geometric figure. In this case, my geometric figure is the rectangle. So now we got to come up with smart vertices. I'm going to call this one right here x, comma, 0. I'm going to call the vertice on the left negative x, comma, 0. Okay, getting really fancy. I'm going to call this vertex up here x, comma, y. And then the one on the left would then be negative x, comma, y. Okay, so how do I find perimeter of that rectangle? What is perimeter? Don't we just add up all the sides? Okay, so what's the length of this side? 2x. So doubling it would give me 4x. So my perimeter is 4x plus, what's the length of this side? 2xy. Just y, because we're just doing the up movement, right? So it's just the length of y. So y and y gives us 2 y's, right? Because left-right movement gives us we add our x's. Up, down is our y's, so our differences of the y's. Okay, so there's my perimeter of this unknown rectangle that we're trying to figure out. So now what we need to do is we need to create a function of just one variable. Well, right now I have a function of x and y. How can I turn this into just a function of x? Well, what did we say y was equal to up here? 20 minus 0.32 x squared. Because isn't it true that xy is a point on this function? So if I know that this point's on this function, then I can just plug this in place of my y. So I get 4x plus 2 times 20 minus 0.32 x squared. All right, I'm going to cheat. Tell you what that is when we simplify that out. It's 0.64 x squared plus 4x plus 40 is our function in terms of x. Okay, so there's our perimeter of our rectangle in terms of just x variables. So now we're asked to find the maximum perimeters. How do we find the maximum? We find the vertex. How do we find the vertex? Negative b over 2a, right? So now I'm going to do that. So now we're going to find the vertex of this function. So we're going to do x equals negative b over 2a. So negative 4 over 2 times negative 0.64, which is 3.125. That's our x-coordinate of our vertex. But to find our max or our min, we need to find the y-coordinate. So now I need to evaluate my function for 3.125, which is 46.25 feet. be the maximum perimeter of that shed. Okay? So create a diagram, smartly label your vertices, try to make a composition of your functions to get one variable only, and then you're either going to find the max or the minimum of your vertex, depending on the concavity of your parabola. Okay? Not too crazy if you break it down like that. Good. All right, so now we're going to move on to a second type of coordinate proof. Before we get there, we have to remember our Pythagorean theorem. You guys remember Pythagorean theorem? A squared plus b squared equals c squared. When you were in geometry, did they derive the distance formula from the Pythagorean theorem for you?
No, we just treated them as one and the same.
They are one and the same.
I know, we didn't even.
So it wasn't.
We didn't even bother to make any difference.
Okay, so we should do the derivation of it then.
Yeah.
Okay, so here we have our right triangle. Remember, Pythagorean theorem tells us that like squared plus like squared equals hypotenuse squared, right? So a squared plus b squared equals c squared. So now, if we need to do the derivation of it, if I throw that right triangle in quadrant 1 and smartly label my vertices, all right, so I'm going to get rid of this over here. So I think we got our Pythagorean theorem down. A squared plus b squared equals c squared. So if we have one vertex at x sub 1, y sub 1, a second vertex at the right angle at x sub 2, y sub 1, and then the third vertex would be at x sub 2, y sub 2, where does the distance formula come from? Well, let's use the Pythagorean theorem. What would be, and let's, just to make our lives easier, I'm going to label this as P, this is R, and this is Q, just for word purposes, less words I have to say. If I wanted to find the length of, let's say, PR first, what is the length of PR? Well, we don't quite know, right? Wouldn't it just be the difference of x sub 2 and the difference of your x's? So PR's length would be the absolute value of the difference of our x's. I'm putting absolute value around it because we're talking about a physical distance, so it can't be negative. Because if I did x sub 1 minus x sub 2, it would be negative, so I would just need the absolute value of it. The length of QR would be the difference of my y's, because it's our up and down vertical movement. So the absolute value of y sub 2 minus y sub 1. So now if we do the Pythagorean theorem to solve for PQ, the diagonal, that's my hypotenuse. So PQ squared, your hypotenuse squared, is equal to PR squared plus QR squared. Right? Is that our Pythagorean theorem? Hypotenuse is equal to or hypotenuse squared is equal to leg squared plus leg squared. So now let's plug these in and substitute them in. So now we have the absolute value of x sub 2 minus x sub 1 squared plus the absolute value of y sub 2 minus y sub 1 squared is equal to PQ squared. What happens to an absolute value number when you square it? Doesn't it just always stay positive? So this is kind of like a double unnecessary. Absolute value makes something positive. Squaring something makes positive. So really, when I square those, I can just get rid of the absolute value. And just make those into parentheses. Sorry, I'm running out of space. I should move up to the top. And then how do we undo that square? Square root both sides, right? So now we end up with PQ is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, which do we recognize as the distance formula? Right? So that is your distance formula. So your distance formula is the Pythagorean theorem. We just have to think about our lengths of our sides. Okay, so there's the derivation of the distance formula from the Pythagorean theorem. Kenai?
What is the square root in the square?
No, because of that plus. Good question. That plus does not allow you to be able to do that. If this was multiplication, then yes. Right? So just, if you think about it this way, like if we did the square root of 4 squared plus 10 squared. Well, 4 squared is 16, that's 100, so it's 116, which is not a perfect square. That's not equal to the square root, or sorry, just 4 plus 10, which is 14. Right, if you just did 4 squared, 10 squared, and made it 4 plus 10, that's not the same thing. It would work if it was multiplication, because then you could go right to, the 4 times 10, which would be 40. Okay, so that plus does not allow you to do that. Okay, so distance formula. Make sure you guys have that written down. So the same thing that we just had there. So your distance formula is d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And I'm sure there's some way to make a program for distance formula in your calculator. If you are dying to do it at some point in time when you have spare time, I'm sure you can find a YouTube video where you could program that in. The only problem would be your calculator would give it to you as a decimal as opposed to a simplified radical. Bless you. Okay, so now let's work through some distance formula coordinate proofs. So do you guys remember back in, what chapter is it? Chapter 5, geometry. Maybe you didn't have the same textbook as me, so maybe it's not chapter 5 for where you were. Triangle inequalities. If we know that if a squared plus b squared equals c squared, it has to be a right triangle, right? What if it's not a right triangle? It could be acute, or it could be obtuse, right? So how do we determine whether it's acute or obtuse? Right angle, a squared plus b squared is equal to c squared. What if your c squared was smaller? What kind of triangle do you think it would be? Acute, good. Your c squared was larger, then it's going to be obtuse, right? Think about it visually. All right, so we'll go back to that one. So let's go to example 3. So we're going to, given 3 points, we need to decide whether our triangle is an acute or an obtuse triangle. So we could plot it and make a pretty rough guess of it. But just plotting it doesn't prove it. We need to do a coordinate proof, which means we have to actually use geometry. So we're going to use the distance formula. So let's find the lengths of all those sides of the triangle. So let's find the length of AB. Pause for a second. So the distance, we're taking the difference and squaring the x's. So -5 plus 1 is -4. -4 squared is 16. Subtracting the y's, so 2 plus 3 is 5, so 25. adding that together gets me 41. So I'm just going to leave it as a square root of 41. I'm going to do the same thing from B to C. So B to C. So 3 plus 5 is 8. 8 squared is 64. 4 minus 2 is 2. Squared is 4. That gets me 68. Right now, which one's the bigger of the two? BC is bigger, right? Does everybody see that BC is bigger? Square root of 68 is larger than the square root of 41. Let's do it for the third side, which would be from A to C. So 3 minus a negative, so plus 4, 16. And then 4 and 3, 7, so 49. So adding those together is going to get me, what, 65? Am I doing my mental math correctly? It's Monday morning. All right, so out of the three, top, middle, bottom, which one's the largest? The middle. So I'm going to make this my C. And then it doesn't matter which other ones become your A and your B. So now we're going to check. If my C squared is larger than A squared plus B squared, then I know that my triangle is going to be obtuse. If my C squared is smaller than my A squared plus B squared, then I know that my triangle is going to be acute. So we're saying BC is my C. So let's check. Is the square root of 68 greater than or less than the square root of 41 plus the square root of 65? I mean, we could actually put that in our calculator, but anybody want to guess if it's larger or smaller? I mean, square root of 65 and the square root of 68 are pretty darn close. If I add another square root of 41, I'm going to guess that this is smaller, but I would do that on my calculator. I would do the square root of 68 on my calculator, get the decimal version of it. Then I would do the square root of 41 plus the square root of 65, get the decimal version of that. What does that get me? So square root 68 is about 8.246. Square root of 41 plus the square root of 65. Make sure you close that parenthesis after the 41. That's 14.4, so definitely, yeah. So it's smaller. So what type of triangle do we have, Kenai?
Cube.
Yes.
But,
Question.
Since it's C squared, wouldn't you just square it and then be...
Oh, I forgot to square it.
Wouldn't it be 68 equals...
Yes. I didn't even do it right, but it is acute. You're right. It's squaring it. Square, square, square. So I don't even need my calculator, right? Ay. So it's 68, 41 plus 65, which is definitely smaller. Thank you. Thanks for catching that. Yeah, C squared compared to A squared plus B squared, not just C. Okay? All right. I think we're going to skip the word problem one due to time. I think we got that. Okay, so we've got acute, obtuse, right triangles. How about if I wanted to check whether the points were collinear? Are we there? Yeah. How do we decide whether they're collinear or not? What should be true if my points are collinear? What does collinear mean? I guess let's start there. If you have points that are collinear, that means they're going to be on the same line. Which one's furthest left out of those three? B, right? So we start at B. What would be next? C would be next. And then A. So I want to check the segment addition postulate from your geometry days tells us that BC plus CA should equal BA if they are all on the same line. This is your segment addition postulate. Not that you have to know that word, but for those who care, that's where it comes from. So if the length from B to C plus the length from C to A is equal to the length from B to A, then they must be on the same line. If they're not, then they're not going to be on the same line. Okay? So everybody see where I got that from? So I went furthest left would be the negative x. Then what's your next smallest or largest x would be 0. And then your largest x is 2. So that's how you can figure out the order of it. So what is the length of BC? I'm just going to cheat. I'm going to look at my work. BC was the square root of 20. CA was the square root of 5. BA was the square root of 45. Oops, my plus sign did not happen. Which, if you do that on your calculator, so the square root of 20, close your parenthesis, plus the square root of 5 is about 6.708. The square root of 45, yeah, exactly the same number. So yes, they are collinear. Okay, so we can use the distance formula to determine whether points are collinear or not. If these were not equal, then they would not be collinear. We can use the distance formula to determine whether triangles are a right triangle, obtuse, or acute triangle. Okay. All right, and the last one we're going to do is a coordinate proof on a parallelogram. Everybody good? All right, so midpoint formula. Let's quickly throw that on our notes in case you don't remember it. If you are ever asked to find the midpoint of a line, you just add your x's, divide by 2, add your y's, and divide by 2. So when we strategically label our vertices and we're talking about the midpoint of something, instead of just an x and a y, it's probably wisest to do like a 2x and a 2y. Why? Because then I can divide by 2 and just have an integer coefficient in front of my x and my y's. If I did just x and y and then divide it by 2, then I would have 1/2 x, 1/2 y, which is just gets a little bit funky when doing your coordinate proofs. So whenever you see the word midpoint in anything, so like the midpoint of the segments, prove that it's the midpoint. Use even coefficients in front. So like a 2x or a 2a or a 2b. Put the 2 in front of it, because you can do that, because you can make them whatever vertices you want them to be for your labeling. Okay, I can come back to this slide for those that need it. So here we go, last example. So we're going to prove that the line segments that join the midpoints of the successive sides of any quadrilateral will form a parallelogram. Prove that the line segments joining the midpoints of the successive sides of any quadrilateral form a parallelogram. Okay, so I don't see the word max or min anywhere. So I'm not going to be doing a coordinate proof to come up with a max or a min of a parabolic something or other. But I probably still want to create some type of diagram so I can see what the heck's happening. So the line segments joining the midpoints of a successive sides of a quadrilateral. Okay, so I need a quadrilateral and a coordinate plane. I'm going to put my quadrilateral in quadrant 1, so I don't have to deal with any negatives. Let's see, what points did I pick? I'm going to put point P at the origin, because using 0, 0 is always nice. I'm going to put point S up here at 2b comma 2c. So there's one side of my quadrilateral. And put point Q over here at 2a comma 0. And I'm going to put point R up here at 2d 2e. All right, so there's my quadrilateral. Any quadrilateral. Doesn't have to specifically be a parallelogram. Mine's not. That's okay. So now I need to find all the midpoints of those sides and then connect them. So midpoint, I'm going to call that D. Midpoint, I'm going to call that A. Midpoint, I'm going to call that B. Midpoint up here, I'm going to call that C. So what would be the coordinates of A? Add your x's. 0 plus 2a is 2a. Cut it in half is a. 0 plus 0 is 0. Cut in half is 0. So there are my coordinates of A. My coordinates of B. 2d plus 2a. Cut in half would just be d plus a or a plus d. 2e plus 0 cut in half is just e. My coordinates for C, 2b plus 2d cut in half would be b plus c, or b plus d. B plus d, comma, looks like c plus e. And then d is going to be at B, C. All right, so those points create another quadrilateral when you connect them. I'm supposed to prove that it is a parallelogram, which for it to be a parallelogram, I need to show that my opposite sides are parallel, which means that they need to have the same slope. Right on top of my head. So how do we find slope of lines? Let's do the slope of AD first. So my slope of AD, so subtract your y's. So C minus 0 all over B minus A. So C over B minus A is my slope of DA. If I go to the side opposite of it, that would be CB. So let's find the slope of line segment CB, not D. See if we get the same thing. Subtracting my y's, C plus E minus E would just be C minus E. All over B plus D minus A plus D, so distribute that negative. So that gets us what? B minus A. So those are the same. Check. Do the same thing for your other two line segments. So my slope of DC is going to be C minus the E, so distribute that to a negative E, all over B minus D. So it looks like we get negative E over negative D, which is E over D. And then do the same thing for AB. So I'm just going to go right to it. So we're running out of time. It's going to end up being E over D also. So since my opposite sides have the same slope, we know that they're parallel, which means that it is a parallelogram. Okay, so we could write something like opposite sides are parallel. Therefore, parallelogram. Yeah, running out of space. Okay. All right, so coordinate proofs. All right, your homework for tonight is going to be out of the textbook. I can throw